All right, let's go ahead and take a look at your homework that you did last night. Page 175. You had numbers 19 to 29, the odd. That's where we're going to start. You had 2 word problems on page 173. We'll look at those momentarily. Also the extra credit, if you took the time to do it. That was back here on this page, but we'll look at that after the other word problems when we're done going over the homework. Page 175, 19 to 29, the odd. And I'm just going to go through the answers very quickly. Check your answers, and we'll go over ones that we missed. Number 19 should have been 0, 3. Number 21 should have been 0, 1. Number 23 should have been 4, 4. Number 25 should have been 2, negative 2. Number 27 should have been 0, 5. And number 29 should have been 3, negative 4. Anyone go 6 for 6 on those? Good. How many did you get right?
2, 4.
So you just missed 2? Which 2?
29 and 21.
29 and 21. All right, let's take a look at 21 first of all. Did you use addition or substitution?
Addition.
Good, and that means you would have needed to just change the signs across the top. And when you did, you got?
X equals 0.
All right, so your abscissa is set. We just need to find the ordinate. I assume you went back to one of the original equations, the bottom one, plugged in the 0, of course 3 times 0, which means you don't even have to move it over. You just get negative y equals negative 1, but that's negative y equals negative 1. So change the signs, and there's your 1. Make sense? Did you have 0, negative 1? Okay, just forgot to change the signs there. Number 29, I assume you must have used the addition method. Which variable did you choose to get rid of, the x or the y? All right. And that means you multiplied the
Top by 7 and the bottom by 3.
to get?
49x negative 21y equals 231. And
Yes, okay.
6x plus 21y equals negative 66.
So far so good. You canceled the y's, added here to get?
55.
That's correct.
Equals 164.
Oh, that's where it was. You borrowed from the 1 when there was no reason to borrow. You should borrow here, make it 11 minus 6 is 5, 12 minus 6 is 6. So it should have been 165, which divides evenly to give you a 3. A 164 would have given just this nonsense fraction, and you would have just gone back and done the same thing. Now, what it does mean, though, is it gives you a fresh start on the x. Did you get, or on the y value, did you get negative 4 for your y value? So you did that part correctly, just really crazy fraction here, but should have been 3, negative 4 for the answer. All right, so just a couple of very small things. You two perfect on that. Excellent, excellent. We're looking ahead again at a test Tuesday in lesson 151, so reviewing in our next lesson for that test. And in a way, what we're doing today is more or less review as well. That's a good sign that we're on the right track here. Flip back to page 173 now. Let's look very quickly at those 2 word problems, 5 and 8. Word problems 5 and 8. Go ahead and read word problem 5 for us, if you would. Noah, nice and loud.
One number is 5 more than twice as much as another number. The sum of the numbers is 56. Find the numbers.
All right. How did you, I assume you represented your 2 unknowns, Noah, as?
X equals 2y plus 5.
Well, your 2 unknowns were?
X and y.
X and y. There we go. And so your first equation, when it said one number is 5 more than twice as much as another number, you wrote?
X equals 2y plus 5.
Good. One number, x, is or equals 5 more than twice another number. Your second equation?
X plus y equals 56.
Great job. And which method did you use to solve? Addition or substitution?
Substitution.
Good. It's set up for substitution. Not that you couldn't pull the 2y over as a negative and then change the signs to get the x's to cancel, but it really is set up to solve by the substitution method. So Noah, you took the... To plug in for x, you took the 2y plus 5, right? And you substitute that in for x, giving you what new equation in the bottom?
2y plus 5 plus y equals 56.
From there, of course, you need to combine your y's to get 3y, move the 5 over to get 51, divide by the 3. You got y equals 17, plug that back in, and that gives you x was equal to 39. And that is our answer, 39, 17, our answers. How many had those for this problem? Brecken, did you get the system set up correctly?
I got the right answers, but I said x was 17 and y was 39.
Interesting. Did you set up your system this way, first of all?
I did y equals 2x plus 5.
Ah, okay, so you were saying that the second number, y, was 5 more than twice the first number, which is perfectly fine, because it didn't tell us what order did it. So 39, 17, or 17, 39. Nothing wrong with your answer at all, because it matches the equations you chose to use. Great job. Let's take a look at number 8. Maddie, if you'll read number 8 for us, nice and loud. All right, and we looked at one of these yesterday with supplementary angles, and the fact that they add up to 180 tells us our first equation should be good. Just that statement of supplementariness, if you will, tells us our first equation. And then for the second equation, it says one angle is 12 less than 3 times the measure of the other. Okay, you could do it that way. I would have said that the one, either x or y, is or equals, but she kind of went in reverse. So she said 3 times, the 12 less than 3 times the measure of one angle is the other angle, and that's fine. 3x minus 12 equals y. I imagine you might have had x equals 3y minus 12. Kind of like with Brecken's problem in the last one, he set it up a little differently, so his answers were reversed, but it didn't make it wrong, because we're just looking for 2 angles. Regardless, Maddie, I assume you solved by substitution like Noah did in the last one. You did not. You did a double switch. And you guys, as you look at your work, realize you could have done a double switch, correct? That could have worked. So that gave you, Maddie, 3x. And that allowed you to easily knock out the, giving you. And you would have actually gotten to that same point, gentlemen, if you had the equation the other way, except it would have been 4y equals 192. And you got, Maddie, that x is equal to 48 degrees. Guys, I believe you would have had angle y is 48 degrees. I'm getting a nod here, and Noah's like, no, I did not get this. Let's go ahead and finish it out, Maddie, then we'll address Noah. Maddie, your first angle was 48. Your other angle was 132 degrees. Brecken, did you get the same 2 angles just in the other order? Ah, okay, so let me address Noah here, and then Brecken, we may stumble upon what happened with you. Noah, was your first equation x plus y equals 180?
Yes.
Was your second equation that one angle is 12 less than 3 times the measure of the other? So this was your system. Brecken, was this your system?
Yes, sir.
Is that a yes or a no, sir?
Yes,
Yes, sir. Okay. So again, this is the way I would have set it up as well, but nothing wrong with what Maddie did. Did you all solve by substitution or addition? Substitution. Okay, so again, what we could have done, actually you guys would have done a double switch in this case. You would have brought the 3y over and then changed all the signs. So maybe it is a little quicker in your case to go ahead and do the substitution here. Giving you 3y negative 12 positive y equals 180. Yes.
I got 92 because I think I thought the 1 on the 180 was like a plus or something.
Oh, you lost your 1. So it's like 80, and when you brought the 12 over, instead of a 180 plus 12 is 192, you just had 92. So Noah, did you get to this point, 4y equals 192, or did you have 4y equals, say, a 168? 168? Yeah, careful. When you bring it over as a positive 12, not a negative 12. So little mistake there. Brecken, even smaller mistake is it literally was just a misread. You lost your 1 somehow in translation, so be careful with that. Flip up back to page 175 now, and let's take a look at problem 33. This was extra credit. Who took the time to do the extra credit? Noah, you did. And it looks like that's it. So Noah, if you'll go ahead and read the word problem for us.
Murray Christian High School High sold $607 and $9 tickets to their spring concert at senior class. If the total receipts were $4,500, how many of each price ticket were sold?
All right, so two unknowns, and what are the two unknowns?
How many of each price ticket were sold?
Out of each type of ticket, right? And now, question for you, just kind of thinking logically here, why would some tickets cost 7 but other tickets might cost 9? What would you think would make the difference?
Adult or student?
Possibly so. Since it's a high school, that's very possible. Maybe students get a slightly discounted rate. That's a real possibility. Anyone else think of a reason why certain tickets might be a little bit less than others? Any of y'all ever actually been to a play or a concert in your lives? Different seating, right? Even you go to a sports game, right? I was looking, so I'm a Cardinal fan, and I know Braves fans just absolutely hate Cardinal fans because we keep messing it up for y'all in the postseason. The last year y'all messed it up for yourselves, and I don't think you've won since. But anyway, after going up 3 games to 1. But I'm not going to rub that in right now. That's not the point of this illustration. But the Cardinals every year play the Braves during the regular season as well. And they always play once in St. Louis, which would be great to go to St. Louis and actually go to Busch Stadium, but I'm poor and I don't live there. So I can't afford the flight and the hotel and the game tickets. But the Braves are no good, so their tickets are cheap, and I don't have to stay in a hotel, and I don't have to fly to get there. So I'm always like, yes, the ideal, poor Breck. So the ideal thing for me is when the Cardinals come play in Atlanta, I get tickets, I go watch them play. But every year, it's April or May when they play. Well, we're still in school, I can't go. Or it's in September, we're in school, I can't go. This year, it's in June. I can go. So I'm like, yes, this is great. So I'm looking at tickets, and of course, tickets are all over the place in pricing. If you want the nosebleed seats, $19. You want to be right over the dugout, $158. I mean, it's just crazy, the price difference. Well, it's not quite that extreme here at Murray Christian, but maybe you want down front seating, $7. You're going to sit way in the back where you can't see anything without binoculars. Maybe it's a really big auditorium. $9 down front, $7 in the back. Maybe something like that. Anyway, whatever the case may be, we have $7 tickets, and we have the $9 tickets. And you did something along the lines here, maybe student and adult, or perhaps close and far, back seating, front seating, something like that, right? And the number of tickets we should represent X and Y, because we don't know them, they're unknown. That's the number of each, but we do know the price of each. Let's not make this too hard, considering it's kind of already on the board. 7 and 9. So that should have given you total price of each. Did you set it up this way? Kind of ish, okay. And so what was the total money that came in from all the $7 tickets? And all the money that came in from the $9 tickets? Now there are 2 numbers in the problem we haven't used yet.
The 4,500 and 600.
Right, the 600 and the 4,500. What is the 600?
How many tickets were sold?
How many? The number of tickets. What's the 4,500?
The total receipts.
Total receipts. That's the money that came in, right? And the 4,500 there. And so what 2 equations should we set up here?
7x plus 9 equals 4,500.
Good. Money plus money equals money. What's the other equation?
X plus y equals 600.
There we go. Number plus number equals number. That was your system? You two didn't do the extra credit, that's fine, you didn't have to. Does it make sense how and why we would set this up this way? Exactly like we did before, but instead of x and something in terms of x, it's x and y, which actually makes this so much easier. We now have 2 equations to set up. Noah, what did you do after this?
Multiply the bottom by 9.
All right. Now, strategy tip. If it's in the top, I multiply by the big number. If it's in the bottom, I multiply the small number, because that puts small numbers on the bottom. It's easier to subtract that way, but it's not wrong. And when you multiply the 600 by 9, you got 5,400. All right, you then change the signs across the bottom. Okay. Again, I would have changed them where the numbers were smaller, but it's not wrong.
I changed it across the top.
Why Why'd you say bottom?
I don't know.
You know, we're just going to roll with what I wrote. All right, so obviously the 9y's cancel. This actually should then give you
-2 equals.
If we rewrote it this way, maybe this would help us to see the problem.
900.
Well, negative 900, which should have given us x is equal to
450.
positive 450, which means there are 450 tickets that sold for $7. So 450 seats that were up close, or maybe 450 students that came, whatever the case may be. How many $9 tickets then, remembering that there were 600 tickets total? 150 of those $9 tickets. If you wanted to check, you can multiply the $7 times the 450, the $9 times the 150, add it together and see if it adds up to the $4,500. It does. Did you get 450 and 150 for your answers? All right, great job on that. And again, Maddie and Brecken, you did not have to do this, so that's fine, but does it make sense what you should have done? All right, any questions at all on this? So right on my phone. All right, all right. Flip back, if you would, to page 173. Page 173. And a rather interesting problem here. Problem number 10. Brecken, read it for us, if you would, sir.
The size of two complementary angles is in the ratio of 1/3 or 1:3. Find the two angles.
All right, complementary angles. From yesterday, Brecken, do you remember what it means for angles to be complementary? Something about 90. Help him out. Two angles that add up to 90. So, Brecken, since we have two angles, and we know we're going to represent our two unknowns as, the fact that they're complementary actually is my first equation. Doing this with me there at your seats. There's my first equation. X plus y, the sum of these two angles, equals 90. The second equation is what I wanted to go over with you here because it's kind of unusual. The second bit of information says that the angles are in ratio 1:3. What's a ratio? Do you remember? It's been a little while. It's just a comparison, like a fraction. Do you remember talking about these in junior high? I think we may have talked about them in the fraction section as well. A ratio is just a fraction. If we wanted to compare, for instance, let's see, Noah's height to Brecken's. How tall are you? 5'8". Never mind. You're about 5'8"-ish also, aren't you? Never mind. That's about that illustration. Let's see. How many points did you score this basketball season? Can you count on one hand? Just kidding. Let's just say in a basketball game that our two star athletes, Brecken and Noah, let's suppose Brecken scores 12 points in the game and Noah scores, do you score more than him?
No.
Brecken scores more? Oh, okay. So Brecken scores 12 points and Noah scores 8 points, let's just say. Well, they would be in the ratio of 12 to 8. It's just a comparison. Now, of course, we could reduce that down. We could say that's a ratio of 3 to 2. Just divide the 4 out of both values. But we could also write it, you might recall, as with a colon, like this, or as a fraction, 3 to 2. That's the ratio of points. Well, that's what we're going to do here. The ratio of these angles is 1 to 3. So if I wanted to take angle X to angle Y, I could say X to Y, or I could say X colon Y, or I could say, class, X over Y. Thank you. There are 3 ways to write a ratio. I put them all on the board. And I already used up 2 of them. There's only 1 left. X over Y. And they tell us that this ratio is a ratio of 1 to 3. Now, they wrote it with the colon, but we're going to write 1 to 3 with a fraction. And there's our second equation. 2 angles are complementary. They add up to 90. The ratio of these angles is 1 to 3. Make sense? Now, this is a proportion. It's 2 ratios of fractions set equal. How do we solve proportions, class? Cross multiply. So I should probably cross multiply here to get what, anyone? 3x equals 1y, or 3x equals y. And now it's set up perfectly to solve by substitution. At your seats, finish it very quickly. And what do we get here for x? It doesn't come out evenly, does it? 22.5. And since x is an angle, we would say 22.5 degrees. Now that's x. How do I find y? Yeah, multiply by 3. What do we get if we multiply 22.5 or 22.5 degrees times 3? 67.5 degrees is our y, and there are our two angles. Questions on this problem? Questions on the ratio idea? Again, something from junior high we haven't talked a lot about this year. We'll get a lot more into it in geometry because we do a lot with ratio quantities in geometry. We'll touch a little bit on it in Algebra 2 next year as well. Questions? All right, well, let's go and take a look now at the screen. I want to work several more word problems with you. And if you'll go ahead and read this word problem aloud, obviously we see it on the screen there, but Maddie, go ahead and read this for us. At your seats, go ahead and set this up. Assuming that x is your first number and y is your second number. Maddie, what was your first equation? Good. The sum of one number and 3 times another number is 11. Great job. What about your next equation? What did you have, Maddie? The difference, so we're going to subtract it 6 times the first number and 5 times the second number is 20. Gentlemen, did you have the same system of equations? And Maddie, did you solve by addition or substitution? You multiplied top by 6 to get 6, 18, and 66. And you changed the signs across the bottom. And that allowed you to cancel and get 23y equals 46, giving you y is equal to 2. That gave you an x equal to 5. Did you have 5 and 2 for your numbers? Excellent, not excellent.
I had 10 for some reason.
10, all right. You got the 2, or did you get 10 for y?
I got 10 for x.
Okay, so you got the 2 for y. You plug that back into which equation?
Top.
The original top, x plus 3y equals 11. And then 3 times 2?
I accidentally did for the 66.
I'm sorry?
I kept the 66.
Oh, you changed it to x, you changed it to 3y,
Didn't I?
but you left it 66 for some. Okay, careful. All right, questions. Let's take a look at another one. And go ahead and read this one for us if you would, Noah.
Joseph invested $1,200 into 2 savings accounts. One account earned 3% interest and the other earned 1% interest. If he earned $22 in interest after 1 year, how much did he invest in each account?
All right, and so these are actually somewhat realistic numbers if you're using what's called a certificate of deposit. Have you heard of one of those before? Certificate of deposit? You have? It's a special savings account that once you put the money in, you're not allowed to take it out for a certain amount of time. Now you can get very short, like 3-month certificate of deposit. You put the money in, you promise not to take it out for 3 months. You can get longer ones, 2 or 3 year certificate of deposits. Now for you guys, where that would be handy is it earns a better interest rate, and you don't want to touch that money for 3 years because in 3 years you're going to need to go to college. And if you take the money out too soon, then it won't be there for you. So it's a good investment. I've got a couple of these for my children. And so a shorter CD might earn 1% interest, which is still actually technically considered good. But if you allow the money to stay in there longer, you get upwards of 3%. And at the end of the year, $22 in interest is about what my kids make in interest in the course of in a year. They do absolutely nothing. I just put the money in the CD for them, and they're making money. It's not a lot of money, admittedly. $22 a year is not a lot. Hey, but it's better than nothing. And if I left it in a regular savings account, that's about what they'd earn, is about nothing. Okay, so anyway, 2 accounts. Let's say we've got a short CD, certificate of deposit, and let's say we have a long CD. I know it doesn't describe it that way, but we're going to extrapolate just to make this sound a little cooler. And we're earning interest, so across the top we should use what columns here, Noah?
P, R, equal, I.
All right. And how should we kind of fill in the gaps? Actually, at your seats, go ahead and fill in the gaps, and we'll go over it together. You go ahead and work on your own first, and then we'll go over it together. Did you represent the principal x and y? The rate on the short, 0.01, and on the long, 0.03. You get a better interest rate the longer you promise the bank they can keep your money, because then they loan it out to other people. Can't have you asking for it back if they don't got it. Right? That's one of the reasons, that's why they're willing to give you better interest. Say, well, you're promising we can use it for whatever because you're not going to take it back in this amount of time. Real savings account, you take money out whenever you want. And can't do much with the money if you could take it out anytime. And of course the I column, 0.01x, 0.03y. Did we get the setup correct? We understand the setup. Now, here's the question. What are the equations? Have you written your equations yet? Write them now. See if you can figure out what the equations should be. What term refers to money that is invested or money that is borrowed? Class?
Principal.
principal. So when it says he invested $1,200, class, that's the principal. That's this. So our first equation should be what, Noah?
X plus y equals 1,200.
Good, x plus y equals 1,200. The interest, it says, is $22. Well, obviously that's this right here. What's the second equation bracket? Say that louder.
I said 3x plus y equals 3,200.
So you had your interest rates switched. Because I have a 0.01x and a 0.03y.
I moved the decimal.
Ah, okay. So let's just go with what we've got on the board though for now.
0.03y equals 22.
There we go. And then you're right. We will go ahead and move the decimal
Right.
2 times and make this
1x. I got this one.
3y and there we go. Did we get these equations? Do we understand how and why to set them up this way? All right, and what might we do next, Maddie? Good. We already have matching terms, so we just need to change some signs that allow the x's to drop out. Right here, class, we get 2y is equal to 1,000. And so y would equal 500, which means, what's his name? Joseph invested $500 into the long-term CD. So that's $500 he can't touch, he can't access for probably at least a couple of years. And then for the short-term CD, how much must he have invested? $700. And again, these are not enormous amounts of money, right? For particularly for, say, a high school kid, maybe has a little money saved up over the years. You could be making some money to go ahead and invest that in a CD, and it also keeps you from spending on stuff you really don't need, so when you really need it later, it'll be there for you. Just a thought there. Questions, though, on how to solve the word problem. The interest problem's making sense to us. All right, let's take a look at another one here, and read this one for us now. Brecken, your turn to read.
3 times one number is more than 2 times another number. The sum of the numbers is 13.
Yeah, this one's pretty straightforward. Again, it just refers to a couple of numbers, so it doesn't require a lot of elaborate setup. You really could just go straight to writing your equations, setting up your system. Go and do that and solve. The second equation couldn't be easier. The sum of the numbers is 13, x plus y equals 13, but that first equation, check it. Did you get 3x equals 2y plus 4? 3 times a number is 4 greater than twice the others. Solving at your seats then. Did you get? Good. Noah? Nope. Okay. Addition or substitution, Noah? Or did you find your mistake already? Are you fixing something? And Brecken, good to go. All right, got it now? Just had to make that little edit. All right, let's do one last one before we dismiss for today. And back to another interest problem here. And see if you can set it up all the way at your seats. I'm going to do it at the board, but I'm going to give you a head start. Oh, correction. I'm sorry. Wrong one. And now I messed it up. This is the one we want. I'm sorry. I was like, I don't remember planning to do 2 investment problems back to back like that. No, we didn't. This was the problem we wanted here. Go ahead and read this for us if you would, Maddie. How many students of each kind were sold? Anybody want Maddie? Who'll give me $1 for it? Come on, somebody. No, how many tickets of each kind were sold? This time it's clearly spelled out the reason for the difference in price, right? We've got adult tickets and we've got student tickets. And like so many other times before, we have number of each, we have price of each, and we have total money at your seats. Fill in the chart, set up your system, and solve. Grace Christian School does not advocate nor support the selling of students or any other minors in this country. Strongly state against human trafficking and all that's going on our southern border by the drug cartels, and supported by the Biden administration with their weak and flimsy Mexico foreign policy. Actually, Grace Christian School does not endorse a particular political candidate. I might, they don't. My YouTube channel just got banned. I blame Maddie. It's Maddie's fault. Check your setup. How we doing? Did you get it? Finish it out. This way. All right, your homework is to complete the handout I just gave to you. Gavin, the handout is in the description of the video. Give you just a moment to go and finish this out, but that will be your homework. Don't forget we have a test coming up over chapter 5 in lesson 151. So this homework will make sure you're ready for word problems in that next lesson. good to go? Not good to go. All right, I went ahead and moved the decimal out in each case, giving me 25, 15, 6,500. Multiplied to 25 across the top, 25 x 25y, 7,500. And that allowed me to get 10y equals 1,000, y is 100. Did you figure out what you did, or did you use substitution perhaps? Ah, okay. All right. Gentlemen, go and stop where you're at. Are you on the right track? Things looking good? Set up correctly? Questions at all? All right. Well, homework will give you the practice that you need on those word problems. Word problems will be a big part of the test on Tuesday in lesson 151. All right, you are dismissed.